Right, so let's do 29 and 30 from the practice final exam. This is where we have to solve equations, and the angle is supposed to be between 0 and 2 pi. So it has to be somewhere on our unit circle. So I start by just solving like I would any algebraic equation. 2 times the cosine of x then equals 2. And then I'm going to divide both sides by 2. And I get that the cosine of x equals 1. I take the inverse of each side, and I get that x equals the inverse cosine of 1. So in other words, I'm looking for where on my unit circle is my cosine 1. Right here is the ordered pair 1, 0. That's where cosine is 1. And this has two names. It's called 0 and it's called 2 pi. So x equals 0 and x equals 2 pi. There's no other place on the unit circle where it's positive 1. Over here, it's negative 1, and that would be pi, but it just said positive 1. So there's just two answers, 0 and 2 pi. All right, let's go to number 30. Here we're asked to solve where theta is between 0 and 2 pi, and it's 2 cosine squared of x equals 1. So the first thing I'm going to do is I'm going to divide both sides by 2, and I get cosine squared of x equals 1/2. Then I take the square root. Because I take the square root, it's plus or minus the square root of 1/2. Which is plus or minus, I know the square root of 1 is 1, over the square root of 2. And we know we're not allowed to have radicals in the denominator, so I multiply the numerator and the denominator by the square root of 2 over the square root of 2, because that's really just multiplying by the number 1, and I get plus or minus the square root of 2 over 2. So I am looking for where is my cosine of x plus or minus the square root of 2 over 2. So it's an inverse. I'm looking for an angle. Plus or minus square root of 2 over 2. That happens. Oops, I gotta plug my computer in real fast. I'm going to pause here. And my cosine, which is my x-coordinate, is square root of 2 over 2, positive or negative, at my pi over 4 family, which is pi over 4. This is at 3 pi over 4, that's where it's negative. And then over here at 5 pi over 4, it's negative. And back here at 7 pi over 4, it's positive. So I have 4 answers because it's plus or minus the square root of 2 over 2. Here's another equation that I'm going to solve. I'm going to subtract 2 from each side. And I get that the cosine of x is 0.742. And I take the inverse of each side. And I get that x is the inverse cosine of 0.742. And I know that since cosine is positive here and here. So I need 2 answers. So I'm going to go to my calculator, and you'll notice in this problem 31 it gives you a reminder that your calculator needs to be in radians for this problem. And I do inverse cosine of 0.742. Is that what it is? Yes. And I get 0.735. Let's see, it asks, yes, to round to 3 decimal places. So I get x equals 0.735, and that would be my quadrant 1 answer. But then I also need to find this answer, which would be 2 pi minus the 0.735. So I put that in my calculator. 2 pi minus 0.735, and I get 5.548. So that would be my 5.548. So those are my two answers. Okay. I'm going to go on to problem 32. It's very similar. Okay. I'm going to subtract 2 from each side, and I get that the sine of x equals 0.654, and I take the inverse of each side. So x is the inverse sine of 0.654, which is positive. And I know that sine is positive in quadrants 1 and 3 because it's the y coordinate. So I'm going to need two answers, a quadrant 1 and a quadrant 3 answer. So second sine 0.654, and I get 0.713. So that's my quadrant 1 answer. And this answer, this is pi, and I'm going backwards, so subtracting. So pi minus 0.713 would give me my quadrant 2 answer. So I do pi minus 0.713, and I get 2.429. That would be my quadrant 2 answer. And those are my two answers for 32. Right, 33 and 34 have me working with imaginary numbers. I'm told that m is 5 minus 2i and n is 4 plus 3i, and I need to divide m by n. Now, it'd be great if I could just leave my answer like this, that because I is the square root of -1, it's a radical, and I can't have a radical in the denominator, so I multiply by the complex conjugate of the denominator, 4 minus 3i, and I have to do that in the numerator and the denominator, so that all I'm really doing is multiplying by the number 1. So I'm not changing the value of this number, just the look of it. And now I've just got lots of foiling to do. When I FOIL the numerator, I get 20 for the first. The outers, I get minus 15i. My inners, I get negative 8i. In my last term, I get plus 6i squared. But please remember that I squared is -1, so this becomes minus 6. Then I have my denominator. My first term, I get 16. My outer, I get negative 12i. And my inner, I get plus 12i, which are going to cancel. That's what I wanted to happen. And my last term, I get minus 9i squared, which means that's plus 9. Then I get my like terms together in my numerator. 20 and negative 6 is 14, minus 23i, and 16 plus 9 is 25, so this is all over 25, so my final answer is 14 over 25, minus 23 over 25i. Alright, let's look at number 34. Alright, for 34, very similar, except we have a different numerator this time. Again, because of the I in the denominator, I need to multiply by 4 minus 3i in both the numerator and the denominator. And then I need to start foiling. I get 12. Outer terms minus 9i, inner terms minus 20i. Last term plus 15i squared, which is negative 15, since I squared is -1. In the denominator, I get 16 minus 12i plus 12i minus 9i squared. The 9i squared becomes plus 9, and the 12i's cancel. So in the numerator, I have 12 minus 15 is negative 3 minus 29i, all divided by 25. So when I separate it, I get negative 3 over 25 minus 29 over 25i. And that's 34. Okay, so for number 35, we're asked to divide this polynomial by x squared minus 5. Notice that I had to put a placeholder here where there's no x value. And when we divide, we always focus on the first. And I ask myself, what is x to the fourth divided by x squared? And I get x squared. So that goes up here. I take this x squared and I multiply it by everything in the divisor. And I get x to the fourth plus 0x cubed minus 5x squared. Because I'm subtracting, I change all my signs, because subtraction is adding the opposite. That becomes a negative, that becomes a negative, and that becomes a positive. So I am left with negative 2x cubed plus 7x squared plus 10x. Focus on the first. What is negative 2x cubed divided by x squared? And I get negative 2x. So I'll put that up here. Now I multiply this negative 2x by each of these in the divisor. I get negative 2x cubed plus 0x squared plus 10x. Because I'm subtracting, I change my signs. This becomes plus, this becomes minus, this becomes minus. These cancel, so do these, and I'm left with 7x squared plus 0x minus 35. Focus on the first. What is 7x squared divided by x squared? And I get 7. So do plus 7, multiply that, I get 7x squared plus 0x minus 35, which is exactly what I want with a remainder of 0. So here is my answer. Okay. And here is number 36. Again, notice that I put a placeholder where there was not a term. Start by focusing on the first. What is x to the fourth divided by x squared? And I get x squared. So that's what goes here. I'm going to take that x squared and multiply it by each of these terms. I get x to the fourth plus 0x cubed minus 5x squared. Because I'm subtracting, I change my signs to the opposite. This becomes a negative, negative, and this becomes a positive. And I get negative 3x cubed plus 4x squared plus 15x. Focus on the first. Negative 3x cubed divided by x squared is negative 3x. Take that negative 3x and multiply it by each term in the divisor. Negative 3x cubed plus 0x squared plus 15x. Change my signs because I'm subtracting. Positive, negative, negative. And both the first and the last terms cancel here. And I get 4x squared 0x minus 20. Focus on the first. 4x squared divided by x squared is 4. And I get, when I take that 4 and multiply by each of these terms, 4x squared, 0x, negative 20. I've got the exact same thing, so I get a remainder of 0. And there's my answer.